Let me try something. I will just pass this text and I will ask Copilot to summarize it. Tell me the sentiment and extract the key point. And it just did all of that in one go. No setup, no different tools, just one question. Pretty impressive, right? But how can one AI model perform so many different text analysis tasks? How does it know when to summarize, detect sentiment, or extract key information just from prompt? And more importantly, how can developers use this in their applications? If you are wondering that, you are in the right place. Hi, I'm Sarah Alali, Senior Technical Trainer at Microsoft, specializing in AI, Copilot, and building intelligent and secure applications on Microsoft Azure. I have a PhD in computer science and 12 years teaching training experience. This course covers 12 sessions, where we will dive into core AI concepts in Azure and learn how to turn ideas into real application using modern tools like Microsoft Foundry. In session number 6, we will cover how to get started with text analysis in Azure. I will show you how general-purpose AI models can analyze text using simple prompts and how to use them versus more structured language services. Let's get started with text analysis in Foundry. General-purpose AI models in Foundry rely on natural language prompts to analyze text and return insights. You don't train them, you don't configure them, you just ask. Models like GPT-4.1 Mini are trained on massive amount of text. Because of that, they can handle many text analysis tasks right out of the box. Everything is driven by plain prompts. What can these models do? A single model can perform tasks like extracting key phrases, recognizing people, places, dates, also analyzing sentiment, or maybe summarizing text, or classifying content, even translating language. And you can combine several of these tasks in one conversation. We have covered these tasks in a previous session. I recommend that you go watch it to have a good understanding of natural language processing basics. Here's the key takeaway. The same general-purpose AI model can do all of this. No separate models, no special setup, you just change the prompt. This supports real business scenarios, such as indexing documents for search, filtering spam email, understanding chatbot user intent, categorizing articles and content feeds, and maybe analyzing customer feedback. General-purpose AI models in Foundry are powerful. They are flexible, require no data science expertise, and let you get started with text analysis quickly. This was the general-purpose AI models. What they can do: analyze text using prompts. Now let's look at another approach in Foundry: Azure Language and Foundry Tools. These are purpose-built tools designed for specific text analysis tasks. What makes Azure Language Tools different? Azure Language Tools are specialized. They don't try to be creative. They focus on accuracy, consistency, and structure. They use statistical and linguistic techniques to produce predictable results, structured output, and consistent responses. That makes them ideal for automated pipelines and business-critical scenarios. Okay, let's walk through the main capabilities of Azure Language and Foundry tools using simple example. Language detection automatically detects the language or dialect of a text. For example, if a system receives a message like, "Hello, I need help," "Bonjour, j'ai besoin d'aide," Azure Language can automatically detect that it is English and French. This enables routing messages to the right system support, translating content automatically, and supporting global applications. PII extraction identifies personally identifiable information, such as names, phone numbers, email address, or medical data. From a text, Azure Language can detect person name, email address, and date. This is critical for privacy and compliance, automatically redacting sensitive data and handling regulated information safely. Named entity recognition identifies structured entities in text, detects person, organization, location, and data. Azure Language also includes health-specific text analytics. These tools are designed to analyze medical text and extract medical conditions, treatments, and symptoms. They support healthcare scenarios while respecting privacy and compliance requirements without requiring healthcare AI expertise from developers. At this point, we have seen two different ways to analyze text in Foundry. Naturally, the next question is which one you should use and when. The answer isn't technical, it's practical. Foundry offers two complementary approaches to text analysis, and each one is designed for a different kind of scenario. Understanding the difference helps you make the right choice from the start. Let's start with general-purpose AI models. You use these models when you need flexible conversational analysis and natural language responses. They shine when you want to explore text, combine multiple tasks, or interact with humans. You can ask one model to summarize a document, detect sentiment, identify entities, and explain the main idea all in single conversation. Because these models are prompt-driven. You simply describe what you want, and the model figures it out. This makes them ideal for chatbots, AI assistants, human-in-the-loop workflow, and exploratory analysis where some variability in the output is acceptable and even useful. Now let's contrast that with Azure Language Tools in Foundry. These are purpose-built language services designed for specific text analysis tasks. Instead of flexibility, their strength is reliability. They produce consistent, structured, and deterministic output every time. You use them when you are building automated pipelines, working with regulated or sensitive data, or when your system depends on predictable results. For example, if you are scanning thousands of documents to detect personal data, redact sensitive information, or apply compliance rules, you don't want creative variation. You want precision. Azure Language Tools are built exactly for that. This leads to an important takeaway. Foundry doesn't force you into one approach. The Foundry portal gives you access to both. On one side, you have general-purpose AI models that handle broad language tasks through natural language prompts. On the other hand, you have purpose-built-in Azure Language Tools that return structured deterministic results. The goal isn't to choose one forever, but to choose the right tool for the job. Foundry gives you both options in one platform, making it easier for you to build text analysis solutions that are not only powerful, but also reliable and production-ready. So far, we have seen how text analysis works in Foundry and how to choose the right method. Now let's look at how this is actually used in client applications. Client applications are the apps that put text analysis to work in the real world. They may be web apps, background services, or maybe automated workflows. A client application connects to AI models or language services programmatically. It does this using APIs, which are simply a way for software systems to talk to each other. To make this easier, developers usually rely on client libraries, which provide ready-made code so applications can call AI services securely and correctly. In Foundry, there are two main approaches for client applications. The first approach uses general-purpose AI models that we talked about previously. Access through libraries like the OpenAI Python library, and this works best when applications need flexible conversational analysis. For example, an app may send a customer message to model and ask it to summarize the issue, detect sentiment, and explain intent, all in one request. The second approach uses Azure Language tools, accessed through the Azure Language SDK. This is ideal when applications need consistent and structured results, such as detecting personal information, classifying documents, or running compliance checks in automated pipelines. A single client application can even use both approaches together. It may use a general-purpose model to help humans understand text, and maybe Azure Language tools to reliably automate decisions. Now, let's look at how a client application actually uses general-purpose AI models through the OpenAI API in Foundry. An example is in the slide. But let's understand at a high level, the code flows in a simple and logical sequence. You don't need to understand every line, just understand the flow. The first thing the client application does is to import the libraries it needs. Typically, this includes standard tools to read configuration values, helper library to load environment variables, and also the OpenAI library itself. This prepares the app to securely connect to the AI service. Next, the application loads configuration values from environment variable. This is done using a .environment or env file and utilities like load .NET environment and also OS get environment. Here is where values such as the Azure OpenAI endpoint, the model deployment name, and the API key from your Foundry project are read securely. Nothing sensitive is hard-coded into the source code. Once configuration is loaded, the application creates a client object. This is done using the OpenAI class, passing in the endpoint and API key. From this point on, the client object represents an authenticated connection to the AI model. The application can now send a request using the client.responseCreate method. This is where the actual text analysis happens. The app submits a prompt, such as asking to summarize text or analyze sentiment, and the model generates a response. After the response comes back, the application extracts and displays the results. This might be a summary, a sentiment explanation, or maybe another natural language insight that becomes part of the workflow. One important detail to remember is that responses can vary slightly between calls. That's because general-purpose AI models are probabilistic. This makes them especially well-suited for flexible conversational style analysis, such as assistance and exploratory scenarios. Now let's look at the second way client applications perform text analysis in Foundry, using the Azure Language SDK. Now let's walk through this code on the slide together and understand what is happening without diving into low-level details. At the top, the application imports two key classes. Text Analytics Client is the main client used to send text to Azure Language Services. And Azure Key Credentials is used to authenticate securely using an API key from Foundry. At this point, nothing is running yet. We are just preparing the tools we need. Next, the code creates a credential object using your Foundry project key. This is how the application proves it's allowed to call the service. Immediately after that, we create a text analytics client. This client is initialized with two things: the language service endpoint and the credentials. From here on, this client represents a secure connection to Azure Language in Foundry. Now we reach the data itself. The documents variable contains the text we want to analyze. In this example, it's a simple sentence about attending a Microsoft AI conference in Las Vegas. This is important. Azure Language tools are designed to work with documents, and they scale easily to many documents at once. Next, the application calls recognize entities. This sends the document to Azure Language, which runs named entity recognition automatically. No prompts, no creativity, just structured analysis. When the results come back, the application loops through the detected entities and print them one by one. Each entity is already identified, categorized, and structured. For example, names, locations, and dates are clearly labeled. This predictability is what makes Azure Language tools ideal for automated pipelines and production systems. In the previous slide, we saw how the recognize entities methods helps identify people, locations, organization, and dates in text. What is important is that we use the same Azure Language SDK and the same text analytics client library to call other methods as well. For example, with the same client, we can run language detection with the detect language method to identify the language of incoming text, which is often the first step in multilingual workflow. And we can also call PII detection with recognize PII entities method, which focuses on privacy. It identifies sensitive personal information like name, phone numbers, email address, making it easier to redact data and stay compliant. So, with one library, one endpoint, and one authenticated client, we can perform entity recognition, language detection, and PII detection, all returning structured and reliable results for production system. Now let's look at how Azure Language Service can be used inside an AI agent. Up to now, we have used Azure Language tools directly in client application. But in Foundry, these same language capabilities can also be connected to agents. This is done using something called the Model Context Protocol, or MCP. What is MCP in simple terms? MCP is a standard way for agents to discover and use tools safely. Think of it like a plug-and-play connection. Instead of hard-coding logics, the agent is given access to tools like Azure Language and can decide when to use them. In this case, the Azure Language MCP server exposes language capabilities such as language detection, entity recognition, PII detection, and also text analytics for health. To connect an agent to Azure Language, we configure the Foundry response, the credentials, and the MCP connection. Once connected, Azure Language becomes a tool the agent can call when it needs structured language analysis. For example, an agent helping with customer emails can decide to first detect the language, then check for sensitive personal data, and only then continue the conversation. All of this happens automatically inside the agent workflow. An important part of this setup is governance. Agents don't get free access to tools by default. Every tool call must be explicitly approved. Foundry lets you choose a one-time approval, always allow these specific tools, or maybe always allow all tools for this agent. This ensures that agents act only within approved boundaries, which is critical for enterprise and regulated scenarios. Imagine a Copilot style agent that helps process support tickets. When a message arrives, the agent can use Azure Language to detect the language, then check for personal information using PII detection, and only then generate safe response. The language analysis is handled by Azure Language. The reasoning and conversation are handled by the agent. This is how real-world Copilot and agentic workflow are built in Foundry. Now, let's do a quick exercise where we will explore text analysis with general-purpose models and Azure Language in Foundry Tools for key phrase extraction, named entity recognition, sentiment analysis, language detection, and PII reduction. You can also practice this exercise in your own environment by accessing the lab steps in the link that you can see on the screen, or by visiting the AI-901 learning path through the Microsoft Learn platform. Let's go. In this exercise, we are going to access Microsoft Foundry to try out this platform by creating an AI application and explore common text analysis technique by using the two approach, general-purpose AI model and also purpose-built language tools that we talked about them during this course. So at the beginning, we're going to access the Microsoft Foundry. Always you go to ai.azure.com. We're going to keep working on the same project that we start with it from the beginning of this course, which is the Foundry demo project. And we are going to this time focus in different model, which is the model GPT 4.1, not the GPT 4.1 mini like the previous demos. So here you have the build if you want to access your model. You have also the discover where you're going to search out your favorite model to try out. We have talked about how we compare models, how we select models, and so on. So I'm getting here to model, going to search for the model that I want to use, which is GPT 4.1. So I just wrote GPT and I can see it here. I can select it. And then I can deploy, can go for deployment the default setting. Just remember that before deploying any model, you have all the information that you need from the section in the quick fact where you can see the model provider, you can see the type, you can see here chat completion, we have the life cycle, general availability, the input type text and image, the output also text, also the context, you can see the input, output that we expect from this model. Plus there is other sections where we can focus on more details about this model, how it does, deployment, benchmark, responsible AI, and license. And I want you to get to a previous session where we discussed all these things in the introductory session. Also, there is the use case here that gives you like information about what you can do, like the key use cases of this model. And since this is going to interest me to do some general purpose, I'm going to focus on it. You have also technical information, the input format, the output format, the model architecture, and other things that may interest you. Now let's move into deploying it with the default settings and getting this model ready to do some really NLP, natural language processing things, starting by the first thing, sentiment analysis. So you can change here the instruction, but I'm going to keep it an AI assistant that helps people find information, so nothing to be changed. And I'm going to start with the chat by putting the playground, this piece of text and asking for the sentiment, if it is positive, neutral, or negative. So here's, I'm asking for the sentiment. So I'm giving it 3 options: positive, neutral, or negative. And I can see here in the text, I have the information about the stay of this person in this hotel, and can definitely detect that it is saying words like experience was outstanding, warm and attentive. The atmosphere here, it might say smooth and relaxing. So you can detect really good words that tell me this positive, convenient, extremely convenient, even confidently recommend this hotel. So I can, as a human, I can detect words that says this is a positive review. So I can see here the sentiment of this review saying it's positive, and it gives me in the analysis the reason why. So I can see the words that I detected as a human: outstanding, warm and attentive, helpful, smooth, relaxing, and so on. Extremely convenient, and confidently recommend this hotel. And I can see also how this cost me as a token, and the time spent to generate the solution. Now let's try out with a different review. So I'm going to ask it, what about this one? Review, and I see here words like, you can see here, disappointed, and other things. So let's detect as a human some words. I was disappointed. Too much longer than expected for the wait. Front desk process. The response felt rushed and unhelpful. The room had an ongoing maintenance issue, inconvenient internet access, noticeable noise from the hallway throughout the night. So we can see here a lot of unhappiness from this customer, expressing that the stay was, let's say, horrible. So, but we said positive, neutral, or negative. So it's going to choose one of them. We can see here is negative. And in an analysis, it's given us or convincing us why it's that. We can see here it reflects disappointment from this processed tool too much. So all the things that we already detected. And we can see here also the tokens that used by this request. All right, so now let's move in, try something else that we can do, which is extract named entities. So I'm going to start a new chat. I'm going to enter a prompt. I'm going to review, for example, list the named entity mentioned in this text. So here we have welcome to Global Innovation Workshop. We're excited to host session in London, Toronto, Chicago, and Austin this spring. So you can see here, Global Innovation Workshop, it's organizational event. We have London location, Toronto location, Chicago location, and Austin location. So all these things was obviously detected. Location, also saying city, even city. It's not only location, but also location, and this is a city. And also saying organization, and this is actually an event in organization. And all of them are picked up from the text that we can see it. All right, so yes, so we have the information. Let's also move on into something else that we can do with text analysis, which is summarizing text, which is something that we use a lot. We find it really, really helpful. So you have a text that I want to summarize, and I'm going to say summarize the following meeting transcript into a single paragraph. So here's the full meeting transcript. I want to pass it out. So when you try out with your model, try out with other things. So you can do the same exercise, or you can be more creative and try more things. So you can see here the text, the same text that we have done in the previous demo, in the previous session. And telling me this meeting team discussed potential places to go for an offsite. So there's different places, and there was a decision on a specific place. So that was like the general purpose models that we use. Example, which is GPT-4.1. Now, why not to move into some specialized language analysis tools that exist in Azure Foundry? So we go to build and model, and we have here, rather than deployment, we have other services. And if you look into the other services, we can see there is some speech translation, and we have also some for language, and that's the one that we want really to focus on. So you can see here we have 3 of them which are focusing on the language. You can see these 3: Azure Language Detection, Text PEE Reduction, also Document PII Reduction. And I'm going to try out with you the language detection and the text PII reduction. So let's start with the language detection. So in here, I can really focus on the language. So this is focusing on the language, but you can see that there is others. I'm going to try out with some symbols we do have in here. I'm doing the language detection, but from here also you can access others. So let's try out with an English. This is a document. This document is in English. I hit detect. I see like 100% it was detected as an English document. Okay. So if I try out something else, like maybe some indie text, same here. It detected like 99% this is an indie text. If we try out maybe French, I can say it's French. I see it's 100% French. If we click like view in the model, you can see here like the information about that. And you have also information about the responsible AI, because this is from Azure, from Microsoft. So you can see here different responsible AI, the quick facts, the license. So you can access it also from the solution itself. I'm going to pass this text, this Spanish text. So we try something external, not something greedy. So you can see here, it 100%, it confidence detected that this is a Spanish text. Also, we have the code section here, where you can, if you want like to use it in your own environment, you can access the code section and you can look out what is the libraries that you need. You can configure to the preferable programming language also. So it is in Python, but still you can put it like JavaScript, C# or Java. And you can see also what is within it. You can copy, paste the code and use it in your maybe Visual Studio Code. You can see that as usual, it's taking like information about the endpoint that is used. So we see here the language key we need to use. We have also the language endpoint that we need to use. The library, to be more specific, we are using Text Analytics Client. We are using Azure Key Credentials also. You can see here Azure from Azure Core.Credential from Azure AI Text Analytics. And you can see here also we have to authenticate the client using the key and endpoint. So we are using Authenticate Client. We provide the Azure Key Credentials. We provide also the endpoint, the other information related to credentials, and then we return the fact that we can finally use it, and we have the information about our text. We can see also here the method for detecting the language of the text, for example, because here we are detecting the language of the text. So it takes out the document and then gets in us the response in return. So if we see here, we are using the method language detection example after having already authenticated with the client with authenticated client. So once we are happy with that, we go to our method detection. We provide the client, and we put in place the document, and we get the response from client detect language method that we are using, and we get finally the response that we expected. We also have here the JSON. So we see here the JSON response. So you can see here for our text was Spanish. So you can see here detected language is Spanish, and also the confidence of that answer that we have. Other thing we want to do really is the PII reduction, or also document PII reduction. So if we go to text PII reduction, we can use also the sample example we have. Let's start out, for example, with legal. So here putting in this, we click on detect. You can see it detected a lot of information here. Date, we do have, we can also hide here the text to see the information. So we here see date, personal type, organization, and it's exactly that. So here we have the address, it's 99% confidence, the US social number, organizations, person, name there. So it gives you in all the text. It's really useful when you want to hide some information for security and compliance. So we can see here each of them are really well hidden with some extra and precisely saying what is this information. We can see also in a JSON format, so our text hidden, completely hidden, and telling me here's the entities. We have here this for this text, which is the August 17th, 2019 is a date, and also give me like the confidence score. Each of them have an ID. It is within entities, and it's telling you the name, the original text, putting it under a category, giving it a type, and giving it more information like offset and confidence score for this that is saying this is 99%, which is sure it's a date. All of them having quite similar information, just going to change the category, the type, and also the value of the confidence score. So we see here Matthew Gomez, it's a person, and giving us the confidence score of 99%. Same here, we do have a code section where we provide also a key endpoint. So let's look into this. So we do here provide the key and the endpoint information. We have the libraries that we need, the text analytics client library, and also the Azure Core Credentials library that you need to use. We can see also here we have information about the authentication. So we do use the key and endpoints. So we here have the text analytic clients that we provide on it, endpoint and credentials, and then return the text analytic client after successfully connect. Then you have the client. So we authenticate the client so we can later be able to do the method for detecting sensitive information with the PII recognition example that we are using. So here's where we are defining the method for detecting, providing the document, calling also the client to recognize PII entities, providing the document and the language, and then we're going to print out the result. So we're going to print out the result that we get from that. So we do it through a loop, and we print out all the results that we have. Okay, so let's try out also other thing here. So you can edit here. I can put an email, for example. So also in an email, it detected like this is a person type, confidence score that we have like 100%, 73%, 75%, 96%. I can unhide also to see it directly and understand what is in it. This response that we see it here is more convenient, but you still can have it like in JSON format, so you can use it directly in your code, or put it directly in your database, or do whatever you want to do. Also, same the code, it's going to be particularly like a little bit similar. The JSON also format is going to be a little bit similar. Just here we are passing other informations input in here and getting different result. Now let's try something else, maybe banking also. So putting banking here, if you click detect, also providing me accurate information related to banking. So it detects social security numbers. I invite you also to try a different example, maybe text that you have already. We can also look into other things. You have also here document PII reduction. So for example, here, this is a medical report. So you detect, and then you get really your report ready to be used while hiding information related to the patients. For example, here, if we zoom a little bit, we hide this information about this person. We only have information about that there is someone is sick and having these specific things that we need to work on it, or without giving exactly information about their passport number or anything else. You can also apply some conversational PII reduction. So you see here, for example, here we have some product troubleshooting. So you can hit like detecting. So here's a full transcript. I'm going to remove all the information about personal information about this customer, so you can save it without having any identifiable information related to your customers. Really, really useful also. So in this exercise, we have done a little bit tour, compared the two tools, general purpose models, and also specialized for in Microsoft Foundry to really do some text analysis that we have done during this demo. So I hope you enjoyed the demo. Let's get back to class. In this session, we discussed how Azure AI Foundry enables text analysis through either flexible, prompt-driven, general-purpose AI models or structured, reliable Azure Language tools, and how to choose and use them in real application and agents. Remember that all these materials is available for free on the Learning Path, and you can find the full Learning Path at the Microsoft Learn platform. This concludes our session. Thanks for joining us for this session. To continue your learning, we encourage you to watch other videos in this course or search out your next favorite topic on Microsoft Learn at aka.ms/learn. Happy learning!